How to assemble an 08M motherboard to make a 3 LED bike light. First, find the download socket. Make sure all 5 legs are vertical and that they fit comfortably onto the PCB, which should snap home like so. Next, find the 10K resistor, brown, black, orange, gold, and bend the legs at 90 degrees to the body. That makes it very quick and easy to fit where R1 is fitted on the board, like so. Press or pull it down completely to the surface of the board, and then bend the legs at 45 degrees so that it doesn't drop out when you turn it upside down. Take the 22K resistor, red, red, orange, gold, bend the legs, fit to the PCB, press home, bend again 45 degrees. Take the protection diode and at the end opposite the band, bend it at 90 degrees. The other may be bent more gently. That places it over the far side of the PCB, like so. That's deliberate. Next, the smoothing capacitor. Not strictly needed, but for the few pence it means the motherboard can be used for other circuits, such as servo control. Okay, the short leg is the negative side, shown by a minus sign. The positive leg is the longer one generally, but is never marked. That fits on top of the other components, deliberately, like so. Okay, the chip socket. This is a turn pin item, top quality but expensive. You can fit the chip directly, depends whether you anticipate reusing. I tend to use a chip socket, unless it's a project such as GCSE. Okay, we've got enough pieces to start some soldering. To stop the chip falling out, sorry, the chip socket, what I usually do is, whilst holding it in with one finger, I solder one leg, like so. Okay, then it can be placed in the holder and everything can be soldered. Wipe the iron, iron on, solder in, watch it flow. Those two are supposed to be joined together. If they're on the same silver piece, they're supposed to be joined together. Probably worth explaining that to pupils. They do get worried about joining things that they shouldn't. Modern PCBs are usually solder resist. That's the green stuff. It keeps solder off the places where you don't want it. Soldering the actual chip from the side of the row often makes it easier, especially for beginners. Okay, snip the legs off. And revisit any that you may have missed due to lack of access. You can solder them one at a time if you want. Depends on the class you have, really. Okay, those are the basic components fitted. Other than the power supply, and of course the LEDs. Generally I'd fit the power supply last, okay, so we'll leave that off to one side. We're using 3 red LEDs. These are high brightness ones, which very often come packaged in clear. The short leg generally goes towards negative. Okay, and therefore the longer leg goes towards positive. Now we're going to be using C0. Okay, what I would do here, since I'm not quite sure where I want to point the LEDs at this point is solder one leg, the long leg, to C0 in this case. Okay, I can then angle and do what I like with that later. C1 takes the second LED, try and get them a similar height, solder the leg, and C2 takes a third LED, as so. Okay, the other three legs will all be joined together and they will go to 0 volts. So when the pins are made high, current will flow through the LED, causing it to light up. And we'll connect that resistor shortly. We also need a push switch. Okay, this is Rapid Electronics' extra miniature version. Will fit onto a panel up to 3mm thick and proves to be quite robust. What we're going to do here is called tinning. Wipe the iron, fresh solder on the leg, like so. Quick as possible. You do not wish to burn the flux away completely. To strip the ends of the wire, I use the wire cutters. Works really well as long as the flat side is pointing away from you. Like so. Tin those also. And then, having tinned them both, you can solder them straight together simply by heating the joint. Like so. Find the middle and snip, and then strip. One end will fit in the 0 volts and the other end fits in C3, like so. Solder those on. Like so. Okay, all that remains is the resistor for the LEDs. Now, it's advantageous for a bike light to angle the LEDs slightly. How you orientate them and fit them into the final case is up to you. This is a recommended battery box. It holds 3 AA cells, which gives you an excellent lifespan. The lid can be secured with a fixing screw if you wish, and it also has a built-in on-off switch, which simplifies some of the building. The leads should go through the stress relief holes. The reason for this is when you solder multi-strand wire, it becomes single-strand wire and will then fatigue quickly. Push one through and fit it into the hole as required, and solder. That can then be pulled tight. Same with the black wire, through the stress relief hole, down into where it should be fixed, and then solder on the back, like so. That can be pulled tight. We can fit the chip, making sure that the semicircular indent at one end matches the socket and that the socket matches the overlay. Press that home. All that remains is to connect 3 negative sides of the LEDs together, and then using a single resistor connect them to 0 volts. Okay, the 0 volt hole has already been used by one end of the switch wire, but I'm just going to solder to the underside of the PCB. I'll pop that in the stand. tin the leg, trim it short, fit it like so, tuck it in around the back of the LEDs, bring the leg round perhaps like that, and then solder. Okay, they are all soldered together. That's it. That's the download socket. Put some cells in the holder. Well, before you do that, check all the soldering, look for solder bridges, look for circuits that are incomplete. There should be 2 spare holes, and we'll program that and show it working in a moment.